Back again with 4 awesome discoveries you probably didn't hear about this week.
The tortoiseshell design is popular. Glasses, earrings, buttons, cats, and now a drug capsule that delivers insulin. In this case, it's more the shell than the design. This capsule contains a small biodegradable needle with a tip made of insulin that is injected after the capsule reaches the stomach. Just like the tortoiseshell allows the tortoise to right itself, the capsule can right itself and release insulin into the stomach wall. The researchers say it's pain-free, and in animals, it's comparable to injections for delivering insulin. Plus, it can be adapted to deliver other protein drugs.
When it gets hot in the hive, bees use their wings to draw hot air out and let cool air in. But researchers have found that instead of spreading out across the hive's entrance, the bees' HVAC team clusters at the hottest areas, which have the highest air outflow. Clustering there allows more cool air to enter the nest because of the physics of friction and flow. They also found different bees start fanning at different temperatures, resulting in continuous ventilation and more stable temperatures. This could provide bio-inspiration for human-made cooling systems. Pretty cool.
Back to the future. Scientists say vast reservoirs of carbon dioxide on the ocean floor, mostly located near hydrothermal vents, could superheat the planet if released. The international team found evidence these reservoirs were destabilized about 17,000 years ago, and the release of CO2 helped warm the planet enough to end the ice age. What triggered the CO2 release? Warming oceans, it appears, and the oceans are warming now. The study makes it clear these recently discovered carbon reservoirs are at risk in the future as oceans warm and should be factored into climate models.
Tropical reefs can flip from vibrant coral clusters to underwater fields of seaweed. Researchers have now determined that both seaweed and coral can exist under the same conditions. But here's the catch. The amount of seaweed-eating herbivores is a major factor in whether the site becomes a coral reef or a seaweed field. The research also shows it's tougher to restore an altered ecosystem to its previous state, like returning a seaweed-covered lagoon to a thriving coral reef, than it is to maintain its initial condition. Could have broad implications for reef conservation.
And there you go. See you next time with 4 more awesome discoveries with funding from NSF.